In this video, we are going to be problem solving using algebraic models. So when we do this, we have a couple steps that we should follow. So first, we should write a verbal model. So we've got to know in words what we are doing. So if I'm talking about distance in kilometers, it's just nice to have the units and everything in words so that I can know or explain it to somebody else. Next, I need to assign labels. So if I'm talking about distance, I might want to call it by the variable d, and I also want to have what it is worth so that I can easily plug the numbers and values in later. Step 3, write an algebraic model. So right here is an algebraic model, and here we have plugged in the values. Once I find my distance and rate, then I can find and solve for time. So these are writing algebraic models. And step 4 tells us to solve. So if I go ahead and have 3250 and 450t, solving means I want to isolate my variable or get my t by itself on one side, so I would need to divide by r. And last but certainly not least is actually answering the questions. So congratulations, you found a value for your time, and it came out to 7.2. But the question actually asked you to solve and round to the nearest minute. So are you going to give them 7.2 minutes with your units, or are you going to give them 7 minutes? Just look at the question and make sure you're careful about answering and giving them what they want. So let's just look at a couple of examples and see if we can set them up. Here in example 1, we are talking about chairlifts. So chairlifts transport snowboarders and skiers to the top of the ski runs. The Iron Horse quad chairlift in Montana carries skiers a distance of 3,250 feet. The chairlift moves at a speed of 450 feet per minute. Find the time it takes the chairlift to travel the entire distance. So I'm talking about a distance, a rate, and time. So I know I want to go ahead and write out my words. Distance equals rate times time. That is a formula we will use. More often than not, if we're looking on the ACT, they might actually give you a more complicated formula, but they'll tell you what each variable is worth. So that means I'm going to go ahead and rewrite distance equals rate times time, d, that is 3250 feet. I know my rate, r, is 450 feet per minute. So that means rewriting my algebraic model by plugging in my values here. I want to go ahead and solve by dividing each side by 450. That becomes 1 and cancels out. Zeros can drop off. And my time is approximately going to equal 7.2. So to answer my question, find the time it takes, and that is about 7 minutes. Or depending on just how they want to answer it, you could say between 7 and 8 minutes. Alright, let's look at another example. Low flow faucets help conserve water. They have a flow rate of at most 2.5 gallons per minute. So there's a rate right here. Alright, I'm just labeling it. To test whether a faucet meets this standard, we want to time how long the faucet takes to fill a 1 gallon. So gallon, that's a volume. The result is 0.3 minutes. So right there, I know that that is time. Alright, find the flow rate. Is it a low flow faucet? So here is my final question. Is it? So it's going to be a yes or no. Alright, so you will be given a formula of volume of the container equals the flow rate times time needed to fill the container, time to fill, alright, and the volume of the container. So I want to plug in what I know. I am going to not be using this 2.5. That's just for comparison at the end. So the volume of the container, that is 1 gallon. 1 gallon. My flow rate is unknown, so I'm just going to put R there. And the time it took me to fill was times 0.3 minutes. Alright, so this is gallons, this is minutes. I want to go ahead and divide that 0.3 minutes. My units cancel out. So R equals approximately 3.3 gallons per minute. So to actually answer my question, is it a low flow faucet? No, 3.3 is greater than 2.5, so it's wasting a little bit more water. So your actual answer is going to be no. And that pretty much concludes this video. We are going to go over a couple more examples just to throw some vocab your way. Linear. We're going to go over some linear examples. So that means we're going to be dealing with equations of lines. And this formula, hopefully you remember this from Algebra 1 and from biology. Especially with graphing with independent and dependent variables. So we will come back to this during class. Have a great weekend.